Hello, and thank you for joining us today for Frost & Sullivan's latest webinar from our industrial practice. Today's event is titled Data Center Investment Opportunities to Fuel Your Growth Pipeline. My name is Anna, and I oversee Frost & Sullivan's Growth, Innovation, and Leadership briefings. Our presenters today are Gautham Gnanajothi, Global Research Director here at Frost & Sullivan. He has over 10 years of experience in management consulting, operations, research analysis, and internal quality auditing. He also has experience in the data center markets, data center infrastructure, backup power, the UPS, gensets, cooling, data center racks, cabinets, and data center services, co-location, and cloud. And our next presenter is Vasanth, Krishnan, Power Analyst here at Frost & Sullivan with over 4 years of research and consulting experience. Vasanth was part of the team that advised a global equipment manufacturer regarding a new product go-to-market strategy, and he's supported competitive benchmarking of public-private financing for energy products in Europe. With that, I would now like to hand the presentation over to Gautham.
Thank you, Anna. First of all, I would like to thank everyone for joining us for this presentation today. My name is Gautham Gnanajothi. I'm a Global Research Director and Head of Best Practices within the Industrial Group of Frost & Sullivan. I'm based in London. So let's get started and have a quick look at the agenda for today's presentation. We will be kicking off the presentation by taking a look at the global data center investment trends and investment forecasts. Followed by this, I will take you through the top 10 trends that are expected to shape the data centers of tomorrow. We will then dive deep into 4 of these trends and talk about the implications of each of these in detail. The first one being modularity or modular design, and then we will look at the role and importance of artificial intelligence in data centers, followed by analyzing the impact of 5G and edge in data centers. We will be concluding the presentation by sharing a few final key takeaways. So here we go. Now this first slide here shows you the total global data center investment forecast between 2017 and 2022. And the investment numbers included here, they include any and all type of investment that actually goes into a data center. We've essentially split the investment into 3 categories. First one is IT investment, obviously, which includes IT equipment such as servers and so on. And then we have facility infrastructure, where you have the construction, you have the power, cooling, security, and things like that. And then finally, the outsourcing investment. So among the 3 segments, we are seeing the fastest growth in outsourcing, whereas investment in IT and facility infrastructure is expected to grow at a relatively slower pace, but still growing steadily. And if you see overall, the global data center investment is expected to grow at a CAGR of around 9.5% over the forecast period. Well, we did see the growth rate coming down just a little bit in 2018 from about 11.6% in 2017 to around 8.5% in 2018. So this was mainly caused by a decline in the investment in the hyperscale cloud segment, especially due to the reduced investments by some of the top 5 or 6 cloud giants. So and I think it's also important to mention that large data centers actually accounted for a majority of the global data center investment in 2017, which roughly accounted for around 70% of the total investment. So looking at the future, what we expect is that we expect the growth rates to definitely increase steadily over the next 4 to 5 years, and we can expect to see a sharp rise in investments on edge data centers post 2021, which will obviously be driven by the advent of 5G. So that was the overall data center investment trends in this slide. Now, moving on, let's take a quick glance at the investment split by data center type, right? So which is enterprise, co-location, and hyperscale cloud. So the enterprise class segment accounted for the biggest portion of the investment in 2017, accounting for 57.4% of the total investment. However, this segment is expected to register the lowest growth rate over the forecast period, which would be around 7% CAGR. On the other hand, co-location is expected to be the fastest growing segment with a CAGR of around 13.5%, and it is expected to occupy or take around 24% of the total investment share by 2022. Now, this is mainly, this is mainly because due to the steady increase in the rate at which, in-house data centers are being transitioned to third-party service providers, mainly for cost benefits and for management benefits. Now, moving on to the next slide, here you can see the investment share by region. So obviously Americas was the biggest region for total investment in 2017 with 39.4% share. Now, Frost & Sullivan estimates that Asia Pacific will take over Americas as the biggest region for data center investment by 2022, accounting for around 41.8% share, and with a CAGR, a very impressive CAGR of 16%. And if you look at the investment in EMEA, it is expected to grow at a steady pace, registering a CAGR of around 10% during the forecast period. North America, and it's also important to mention that North America and Europe are leading the way with high growth in co-location data centers, which is followed by Middle East and Africa, again for co-location, for growth in co-location. Now, in these next two slides, we will be looking at a few trends that are likely to shape the future of data centers. We've also shown the level of impact each of these trends will have in the short, mid, and long terms. So the first one is hybrid model, which is cloud plus combined with traditional. So we know that cloud adoption is definitely gaining momentum. However, having said that, a complete shift away from traditional data centers is unlikely. So instead, what we'll see is an adoption of a hybrid model, and that is more likely. And what we are seeing is an increasing adoption of these outsourcing of the outsourcing model that will actually push data center services to become commoditized. And of course, as a cascading effect, the market is expected to become increasingly price driven. And the next trend we have is that there will be a gradual shift towards higher operating temperatures within the data hall. This is mainly as an effort to enhance energy efficiency. So the impact of this trend will get higher over the mid and the long terms as the end user awareness increases. Excuse me for a second. Sorry about that. I apologize. I do have a bad cold. Sorry about that. Now, moving on, the dominance of emerging economies might actually seem like an obvious trend, but nevertheless, it is definitely one of the key trends, shaping the future of data centers for sure. Now, new data center builds, both medium and large, and even small to an extent, will be concentrated around emerging economies. And the most important thing here to note is that Asia Pacific will be the center of focus, especially Southeast Asian countries like Singapore, Malaysia, which are the hub of data centers anyway, in APAC. And then China is also quite a promising country for in this particular aspect, followed by India, which is a small market but definitely has high potential for high growth rates. Now, alternative power and cooling. So what I mean by that is, we'll start seeing, the adoption of innovative, energy efficient, and advanced power and cooling solutions will happen, and things like when we talk about cooling, things like liquid cooling technologies will definitely gain more traction. However, this will take some time because it's still at a nascent stage, but definitely has a lot of potential, especially for when we talk about high density applications. So those are the top. Those are 5 of the top 10 trends. Moving on to the next slide, we have increased power density. So the increasing data center workload and the consolidation of IT equipment will definitely drive, as we can see, it's already happening, will drive increase in power densities. So what we'll see is that the average power density per rack, kilowatt per rack, will exceed the 12 to 14 kilowatt per rack threshold, mainly post 2020. And then we have next generation or next gen DCIM. So we'll see an increase in DCIM penetration. So basically, the already existing demand for DCIM will drive the need for next generation comprehensive data modeling based DCIM solutions. We're already seeing that happening in some parts of the world, especially developed economies such as North America and Europe will be early adopters. And also, of course, given the rate at which APAC is growing, that is actually also is expected to be closely behind North America and Europe in terms of adoption. So this trend will still have a low impact during the short and midterms, and we'll start seeing the impact level increasing in the long terms. Now, the next for the three or four trends listed down below are quite important, and these are the 4 trends that we will be talking about in detail during the rest of the presentation. First one being modular design or modularity. So modular data centers. When it comes to modular data centers, I have to say we are just scratching the surface. So we will definitely see increasing deployments of plug-and-play data centers, as a means to mainly keep up with technology evolution, and obviously cost saving is another key aspect there. So modularity is something we definitely have to watch out for. It's already there. It's not a new trend, but it's definitely going to shape the future of data centers for sure. Artificial intelligence. This is also a very important trend to watch out for. Artificial AI will transform. This is Frost & Sullivan's strong belief that AI will definitely transform the way data centers operate in the coming years. So, technology advancements in AI will definitely make them, will make a data center truly smart. When I say that, I mean a data center that can actually think for itself and act for itself. And finally, we have edge computing and 5G. Again, extremely crucial trends. The advent of 5G will further accelerate the growth of latency-related applications and will consequently drive data centers closer to the edge of the network. So what will happen? We'll start seeing an increasing deployment of smaller edge data centers that will actually bring, with an intention to bring the compute closer to the end user. Now, moving on to the next slide. There are some. These are some of the key growth drivers for modular data centers. Like I said, we're going to be looking specifically at these 4 trends, starting off with modularity and modular data centers. So these are some of the key growth drivers from a product perspective. Obviously, there are other drivers from a market driver perspective, but when you just look at the product as itself, these are some of the main drivers, which are actually pushing adoption. So the first one is future proofing. So what do I mean by future proofing? It offers high flexibility and it's extremely scalable. So the pay as you grow model actually allows for capacity expansion as and when you need it. So modules can be added when there's an extra capacity is required, or on the other hand, it can be scaled down when infrastructure becomes obsolete. And then we have Sorry. And then we have cost savings. Obviously, it offers savings in both on a capex front and an opex front. So operational expenses are reduced mainly due to the fact that it lowers power, cooling, and other operational expenses, mainly because of right sizing. So from a location perspective, well, the main thing is that site exploitation is maximized. So by offering site-specific floor plans and then using modular advantages to the best effect. So and even more importantly, a modular data center can be deployed in any location. Can be an indoor location or can be an outdoor location. And then the other aspect, also a very important aspect, is that it is highly agile. So the speed of deployment increases significantly. Now, a fully operational data center with modular design can be deployed in a matter of a few months rather than a few years. And finally, we have the efficiency. It offers highly efficient power and cooling because of obviously the flexible nature of the design. So those were some of the key aspects from a product perspective driving the modular data center market ahead. Moving on to the next slide, we have here we can see the evolution of data centers from a traditional building to a prefabricated one to micro modular builds, and then now we are headed towards a smart modular data center with AI capabilities. And also the chart below shows the market size of the modular data center in 2017 and a forecast for 2022. As you can see, it is expected to witness a tremendous growth over the next 5 years. Especially this growth will be further accelerated by edge computing post 2021 to a significant degree. Let's actually look at it in more detail in the following slides. So here we can so basically these next two slides will show you the attractiveness level of end user verticals in terms of modular data center adoption. And then looking at regional attractiveness. So here on this slide, when we look at the split among the vertical segments, IT and telecom together account for over half of the total market. So they are the biggest end user segments for modular data centers. And by 2022, IT would account for 34%, and telecom would occupy around 24% of the total market. And these are also the two fastest growing segments where telecom is expected to register a slightly higher CAGR over the forecast period at 26%, and IT at around 24%. The other three segments are also expected to grow at a healthy rate between 12 and 19%. It's just that it's relatively lower than IT and telecom, but still, these are higher than the market average growth rates of when you consider the traditional data center. So among the three, banking and financial will be ahead in terms of growth rates, while the other segment will occupy a bigger portion of the total market. Now, looking at the regional attractiveness, North America and Europe are mature markets with high end user awareness levels. And as you can see, obviously, these two are the biggest regions combined together. They account for close to 70% of the total market. But from a growth perspective, it's a different story. APAC is expected to be the fastest growing region with a CAGR of around 33.5%. And also by 2022, it is expected to actually take over Europe as the second biggest region, accounting for 28%, of the total market, and fast closing in on North America, which at that time would have around 32% share. Right. Now, let's move on to an even more interesting topic. When I say that, I mean artificial intelligence in data centers. So as I mentioned before, AI will definitely change the way we look at data center operations. And we're not too far away from seeing mainstream data centers that actually think and act for themselves. And even more interestingly, the data center gets smarter every day based on what it has learned. So how is it done? By implementing machine learning and deep learning algorithms. So obviously the next question is, how exactly does it improve data center operations? So we have four key aspects First one, it improves the efficiency of the critical infrastructure. So machine learning-driven intelligence actually offers condition-based maintenance for critical power infrastructure, and ultimately enhancing the efficiency and obviously the other advantages is reduced costs. The main components, as you can imagine, would include smart power, smart cooling, smart DCIM, and things like that. The second one, and in my opinion, one of the most important ones is that it detects and eliminates the outages. So AI can actually influence the data center provider through improved outage monitoring, and it offers advanced predictive analytics that actually make it easier and more reliable to monitor to power levels, cooling levels, and any other potential trouble areas. Then we have improved security. Now, AI makes dealing with cyber threats seamless and highly effective. It's on a constant outlook 24/7 without any human intervention. And finally, we have server optimization. So predictive analysis from AI can also assist a data center in distributing the workload quite efficiently, which reduces the strain on the machines and actually helps the entire data center to work more efficiently. Now, as I mentioned in the previous slide, one of the most pressing issues for data center operators today and has been for a while is unplanned outages. So in this slide here, I wanted to quickly highlight some issues that actually cause the unplanned outages. So if you look at the stats here, it's quite alarming, especially the number of outages caused by human error. Directly or indirectly, doesn't matter. So if you look at the pie chart on the right, it actually tells us that the human error combined with power and cooling failure actually caused nearly 60% of the total unplanned outages in the U.S. in 2017. So the key message here is that AI is placed perfectly to address these issues. Now, real quick, just wanted to highlight some of the sort of the impact in terms of the cost impact caused by some of the recent or relatively recent unplanned data center outages. The Delta airline had to incur a cost of $150 million, Southwest Airline $177 million, and if you look at all these, one of the common sort of in the common issue or the root cause was human or accidental error. Again, a key message here being AI would be a perfect solution to address that. And then finally, to conclude, the topic on AI, I wanted to highlight a few real-world examples of AI implementation, in data centers. First one, of course, is Google. So, as we know, in 2017, Google applied DeepMind's machine learning to its data centers, and it was able to cut down its cooling energy consumption by 40%. I mean, by 40%, just imagine 40% off the cooling costs. And it didn't stop there. So in 2018, Google went on another step. It took the system to the next level. So instead of human implemented recommendations, its AI systems now directly controls data center cooling, of course, remaining under expert supervision of the data center operators. The second example I have is Root data centers. So they've leveraged AI models to create AI personas. So this actually allows their experienced engineers to train their AI personas to recognize things like machine sites, sounds or vibrations, and so on. So mainly using a simplified form of supervised learning. And then finally we have CBRE, which is actually deploying AI-driven data center maintenance tools. So these are quite similar to Apple's Siri or Amazon's Alexa. So this is mainly to help automate some of its data center management processes. So they call their AI persona as REMI, R-E-M-I, which is short for Risk Exposure Mitigation Intelligence. So similar to what Root data centers have done. So the REMI personas, personas will be trained by and eventually working alongside the CBRE's data center staff. So that actually brings us to the end of the first part of this presentation, and I'm going to hand it over to my colleague Vasanth, who will be taking you through the rest of the presentation. Thank you, and over to you, Vasanth.
Yep. Thank you very much for that, Gautham. So my name is Vasanth, and I'll be talking about edge computing and 5G. And starting with the slide, you can see here that we have, starting from GPRS, we have gone on from eGPRS, which is the Enhanced General Packet Radio Service. And from there, we have gone to 3G, which is the third generation, and then from there to 4G. And right now, we are at 5G, the fifth generation of mobile technology. And as many of you know, the Mobile World Congress is happening in Barcelona in February 25th. And manufacturers will be queuing up to unveil their latest products. And in that event, they will also be unveiling 5G-enabled smartphones, which will be able to operate in 5G networks. And in this slide, you can see below that we have listed the data transfer rates, and you can see here that 5G will enable 1 gigabits per second. And how is this exactly possible, and why was this not possible in 4G? Well, 4G operates at a radio frequency of less than 6 gigahertz, whereas 5G will be operating at a radio frequency of 30 gigahertz to 300 gigahertz. Now, this is the key feature, which is the advancement from 4G, which will enable 5G to support multiple applications at a much faster speed. And 5G will also be able to support all forms of internet usage, including machine-to-machine communication and machine-to-consumer communication. Moving on. Okay, so I see that that's a question. So yeah, I will try to be more louder and hope that helps. In this slide, we can see here that 5G will be meeting the needs of the modern world. And what we exactly mean is that, given the amount of subscribers currently and moving forward, there is the requirement of 5G to support multiple end users with different latency needs. And thereby, it supports uninterrupted connectivity, which means 5G will be able to support reliable communication for multiple subscribers globally. It will be able to support different technologies, like I mentioned earlier, which is the machine-to-machine communication devices, machine-to-consumer communication devices. And then 5G will also able to support coexistence of multiple technologies within the same device. For example, it could support 4G devices within a 5G framework, and it will also support network convergence, where it will be able to support multiple networks within the same bandwidth. So these are the specific needs which 5G will be meeting. Moving on. So what are the advantages of 5G for consumers and operators? And as you can see here, latency is one of the main advantages of 5G, and here very low latency at approximately 4 milliseconds. And at the same time, it will support multiple devices, and as you can see from the operator side, it will support IoT services such as driverless cars, connected cars, which we'll be talking about later in this presentation. You can also see that 5G will support data transfer speeds of up to 10 gigabits per second, and it will also support interoperable with previous generation technologies from the operator side. So overall, benefits, when we're talking about benefits, 5G will really push the network technology to the next level, both from a consumer's perspective as well as an operator's perspective. Moving on to the next slide. So what are the applications which 5G will be supporting? And as of now, we are going towards probably a digital future where a lot of technological advancements are happening. And we have listed out what are the possible technologies which we will be seeing in the next decade. And as you can see, augmented reality, industry automation, a self-driving car, UHD screens, real-time gaming from the cloud, smart cities, smart homes and buildings. And these all, if you analyze, will require fast connectivity, which means if there is any lag or delay, that experience will it will deteriorate, and that really calls for next level of communications technology, which 5G will deliver. Moving on to the next slide. So that is 5G, and here we will be talking about edge computing. And as you can see here, edge computing, what it does is that it pushes processing of data as close to the source as possible, which means that the processing will happen, really as close to the user. So if a user is located somewhere, in his city, and the processing, it's a high chance that will happen within 100 or 200 or 300 kilometers within his city, rather than going some other region or continent or countries. That is how edge computing really pushes the boundaries when it comes to pushing the data center infrastructure. And what it does is that it processes the data as close to the source, and it sends the data back to the user. And the necessary data which needs to be stored on the cloud, that can be stored on the cloud, and the data which needs to be fed back to the user, that will be fed back to the user. Now, in the case of a centralized computing system, this is not the case. Well, the data will transfer the entire kilometer. It will go to the central framework of data centers. Then the data will be processed, and that will be sent back to the user. Now, edge computing cuts that route. It simplifies the process, and it's just adds another layer to the existing current computing infrastructure. So what is exactly the need for edge computing? Well, data volume is definitely going to grow, and according to our research, by 2025, it will definitely go up to 150 zettabytes, and that is a massive amount of data which needs to be managed, processed, and fed back to the user. And another key reason is that while cloud computing occupies a major share of current data centers, it will not be able to support such massive amounts of data unless such massive amounts of investments in cloud infrastructure takes place. And this edge computing actually, simplifies this process, and it allows, the processing of data happening before it reaches the cloud data centers. And what it also does is that it reduces the amount of investment which the data center providers need to invest in their infrastructure, and they can push this investment towards edge data centers where they can collaborate with multiple providers. Another key reason is that 5G will also together with edge will reduce latency. And as we have seen earlier, latency speeds of up to less than 4 milliseconds would be possible in edge computing together with 5G. And expanding on that, as we can see here, Frost and Sullivan, through multiple primary interviews and research, has identified that as we stand of 2018, the current revenue forecast for edge data center stands at 942 million. And as you can see here, by 2022, we forecast that it will grow to about 3.6 billion at a CAGR of 40%. And this is a massive growth, and this is being boosted by technology such as 5G, and especially when 5G is rolled out in full scale, which we expect to happen by 2021. This market will start to boom, and and this will start to explode after post 2021. And also another key reason for this boom is that the edge data centers is attractive for all data center providers, and this is not specific to an enterprise class provider or a co-location provider or a cloud provider. It is attractive for all classes of providers, and we'll be seeing that later in this presentation. And okay, so we have a poll question, and I'm gonna hand over the mic to Anna.
Thank you. Yes, I have pushed out our poll question, so audience members, if you can just take a moment to select one answer, and we'll reveal the results in about a minute. So the poll question is, which region do you think will grow the fastest in terms of edge data center deployments over the next 5 to 7 years? Is it North America, Europe, APAC, or the rest of the world? So we'll give about a minute here and reveal the results shortly.
Okay, I can see that we've started getting votes. I'll just repeat that again if anybody's tuning in right now. So which region do you think will grow the fastest in terms of edge data center deployments over the next 5 to 7 years? Will it be North America? Will it be Europe? Or will it be APAC? Or will it be the rest of the world?
Okay, so we have the results in. And so it looks like we have, there's a split. It looks like North America and Europe are at 37%, and North America and APAC are at 37%, and it's going to be 25% for Europe.
Okay, super. And we'll be discussing about, the geographic split later in this presentation as well, and we can see whether, the audience are right. So I'll be continuing this presentation and moving forward. So in this slide, what Frost & Sullivan has done is that we have split the revenue forecast into different segments. We have identified 3 segments. The first one being small, up to 250 kilowatts. The second one being medium, 250 to 1 megawatt, and large, which is greater than 1 megawatt. And as you can see here, in 2018, a large edge data centers occupy 46.38%. And you can see here in 2022, it comes down sharply to 28.30%. And small actually goes from 20.95% to 45.40%. Now, one of the key reasons is that small data centers, small edge data centers, is extremely attractive for a lot of participants in the market, and especially telecom operators, due to its modularity and the traction it would gain due to its size and where it can be located under the telecom towers. So the location, the modularity, and are adding to small edge data centers capabilities. And as a result, we are seeing 25% increase from in market share size from 2018 to 22. And as you can also see here, from 2018 to 2022. The market grows at a CAGR of 36.3%, which is again a massive increase. So moving on to the next slide. We have talked about next-gen applications, and we'll just be talking more a bit deeper about next-gen applications. And many of you might know that augmented reality and virtual reality are being pursued by tech giants currently, such as Google, Amazon, and these next-gen applications will probably be in 50% of the homes at least over the next 10 years, and these applications will require low latency processing, and this will be only possible due to the advent of edge data centers. And this will enable a reaction time of less than 5 milliseconds. And as an example, if there is any critical failure in a power plant and the technician is using an augmented reality headset to solve the problem, and if there's an edge data center located close by, that data can transfer from the technician to the edge data center and then come back to the technician rather than going to a centralized data center and then coming back, which delays the response time. And especially in critical applications, this will be really an advantage for edge data centers. And listed below, we have autonomous cars, and autonomous cars. Once they are fully mobilized and become operational, they are likely to generate 3.6 terabytes of data per hour. That's a massive amount of data. However, the primary functions, will be managed in-house, and which means that if there is any specific input which is required with the autonomous car, within, less than, milliseconds, then that will be only possible by the advent of edge data centers. And that is because, again, edge data centers are located close to the source, and the advent of 5G will bring in, faster, data transfer rates, and this will enable next generation of applications to, enable a great success story for them. And in addition to the next generation of applications which we saw previously, there are more number of applications which are currently under research or currently in use. And amongst those are connected cars, cars which are enabled internet connectivity. This will definitely be growing in the next 10 years. And alongside that, we have the Internet of Things, which enables machine-to-machine communication and machine-to-consumer communication. And this is also a massive market, and it requires low latency processing. We also have, the example of NVIDIA Shield, where NVIDIA is trying to unveil, real-time cloud-based, real-time gaming. So, it's like I'm using the internet for playing real-time games, and it is not just, small level of games. It'll be massive games, which, we're playing on PS4 or the computers. And all these next-gen applications are definitely growing in the next, 5 to 10 years. And they will also generate data, and to be successful, they will require faster processing. And if that doesn't happen, then, or even, for example, when I'm playing a game real time through a cloud data center, and if I'm seeing lags of, probably 5 seconds or 6 seconds, that will deteriorate my gaming experience. And edge data centers will truly, enhance the capabilities on that front. And moving forward, Frost & Sullivan has identified all the market participants currently in edge data centers. And as you can see here, the edge data centers, like I mentioned before, are attractive for all class of data center providers. So we have enterprise class data center providers, we have wholesale and retail colo providers, and we also have specialist edge players who focus on specific edge data centers. And we also have cloud providers. And in addition to that, we also have, modular providers and micro modular providers. And like I mentioned before, the edge, data centers, it has a critical role to play in some form for all data center providers. For example, if we take, a cloud data center provider, and if they are looking at edge data centers to boost their capability, they'll be looking at, either expanding their cloud data centers to an edge cloud data center, adding another layer for processing, and, or they might even go for a co-location provider who has an edge data center somewhere. And another key, trend that we are seeing is data center providers are targeting Tier 2 and Tier 3 cities in USA, Europe, and APAC. This is mainly because that layer will be in those Tier 2 and Tier 3 cities. And a lot of growth is being seen in Tier 2 and Tier 3 cities, where the population, the growth, the number of data coming from these cities is expected to grow in the next 10 years. And considering all that, all the edge data center providers are finding Tier 2 and Tier 3 cities across USA, Europe, and APAC to establish their data centers. So, what are the key factors, does an edge data center provider or somebody who's looking at edge data centers, what should they consider before, they go for an edge data center? Well, the three key, factors are proximity, security, and connectivity. And when you say proximity, it means, reducing the distance between the data center and the user. Security means, providing reliable security to the data center. It might be remotely managed. It might be, physically they might be present if that's possible. And connectivity means a seamless connectivity for the user, which means close, almost zero downtime, when possible. And we have explained certain factors which we think are really important to consider. And the first one is business requirement. So if an enterprise is looking at an edge data center, what is the business requirement for them? So that has to be analyzed first. And then the next one would be location. Like I mentioned earlier, Tier 2 and Tier 3 cities offer the most attractive propositions for edge. So would that work for that enterprise? The third one would be method of deployment. How would they be deploying the edge data center? Would they specifically create an architecture separately for edge data centers, and will they be managing that, or will they be collaborating with another cloud player or a co-location player to deploy the edge data centers? And then the next one would be cost to benefit. So considering the investment which they're going to put in to the edge data center, what is going to be the benefit in the long run, and what are the costs which they are going to be paying for? And the next one would be electricity source. Would they be powering up with a renewable electricity source to save upon energy bills? And remember, 5G is also an added advantage, so that should also be considered, with regards to where will 5G be, implemented moving forward. The next 5 years, is 5G being implemented by specific network operators in Tier 2 and Tier 3 cities? What are the attractive locations, where 5G is being implemented? And the next one would be bandwidth. So, what is the level of bandwidth that the edge data centers will be, provided with? And the next one being critical infrastructure. What kind of critical infrastructure requirements will be, suited for the data centers, which is required, at your specific location? And who are the providers which you'll be choosing, and will they be, suit your requirements? The next one will be scalability, and in this point, we're talking about scaling up your edge data centers. So would they be located, as close as possible within kilometers, or how would, if I want to scale my edge data center within a specific region, how would I be scaling that? And then finally, risk management. So we have to consider all the risks associated with deploying edge data centers with regards to my strategy risks, any subcontracting risks, in the overall risk strategy. And again, to emphasize, the three key factors are proximity, like I said earlier, as close to the source as possible. And another one would be security, providing reliability and confidence to the the user, and the another one being connectivity. And another point which also I would like to emphasize is that of 5G, where the advent of 5G will really boost the capability of edge data centers. And the data center providers have to monitor, sorry, the data center providers have to monitor where 5G is implemented going forward in the next 5 years, and which location is likely to have the best 5G capabilities, to sorry for that, to enable seamless connectivity. And we have almost reached the end of the presentation, and the final concluding thoughts are summed up here. And as you can see here, which Gautham talked about earlier, prefabricated modular data centers, they really have the potential to overshadow traditional, data centers in the long run, given their, their structure, their scalability, and their compactness, and their capabilities as well. Like also Gautham mentioned earlier, AI, artificial intelligence, will make a data center truly smart, where it will, imbibe the capability to the data center to truly, think and act on its own, without, any interventions. So that is really going to be an absolute game changer as well. And 5G, will boost the edge data center, landscape, and it will really support latency-sensitive applications. And this will really boost on the data center providers' capabilities as well. And the last one being edge data centers, especially post 2021, when 5G is being implemented at full scale, which we expect. That is where edge data centers will start to boom. And in this, when this boom happens, there's a high possibility that collaboration between multiple stakeholders occurs in the data center ecosystem, where a co-location provider would be able to offer edge data centers to a cloud provider or an enterprise provider, and cloud data center provider might look to expand their edge data centers, and they will be truly supporting collaborations as we move forward. And with this, I will hand over the mic to Anna.
Thank you. We have some time for several questions, and so any questions that we do not get to, the team will get back with you. So let's go ahead and get started. Our first question here, you mentioned the vertical attractiveness for modular data centers. How about applications? What are the attractive end-user applications?
Right. Hi, this is Gautham. I'll take that, Anna. Thank you for the question. So in terms of, if I understand the question, so in terms of the attractiveness of applications for modular data centers, what we've done is we've looked at four segments in terms of applications, which is we've got disaster recovery. Obviously, edge computing is a very important application. Then we have data center augmentation, and then we have starter or new data centers. So looking at the attractiveness level, absolutely, from what we've seen from the presentation as well, the most attractive application with the highest growth rates over the next 5 or 7 years is without a doubt edge computing. So edge computing applications are expected to be the fastest growing with around 35-36% CAGR. But of course, as you also mentioned, it is quite a small segment at this point, with about 15 to 17% share of the entire modular data center market. But in terms of growth, that's going to be the absolute most attractive one, followed by data center augmentation and starter data centers, which actually occupy quite a larger portion of the market when compared to edge computing. So short answer is the most attractive application would be edge computing, and then followed by data center augmentation, and then starter or new data centers.
Thank you, Gautham. Our next question, what does edge data centers mean to cloud, co-location, and enterprise class providers?
Anna, I will take that. My name is Vasanth, and as as I mentioned earlier, the edge data centers is attractive for all class of data centers, and it is attractive for cloud data center providers. It is attractive for co-location data center providers, and it is also attractive for enterprise data center providers. Now, individually, if we take a cloud data center provider, what they can do is they can, add another cloud-based edge data center, which will give them another layer of processing which they can use and send back to the user. Or they can go to a co-location provider for, supporting their data center portfolio. If we are talking about enterprise class providers, they can go to a co-location provider for supporting their portfolio for an edge data center, or they can start building an edge portfolio of data centers, And when we are talking about co-location data center providers, they will look to expand their, capabilities by adding edge data centers in Tier 2 and Tier 3 cities. Summing it all up, edge data centers are an attractive proposition for all class of data center providers, and they will, collaborate between each other where requirements arises to suit their, capabilities.
Thank you, Vasanth. And we have time for one more question here. What would you say is the average size of an edge data center?
Right, Gautham here again. It's a very good question, and also a tricky one. The reason why is there's obviously edge is a relatively new concept, and when we talk about edge, there's a lot of discussion and debate in the industry about what exactly is an edge, and because in fairness, edge could mean one thing to someone and a different thing to someone else. It could mean something for a co-location provider. At the same time, it could mean something else for a cloud provider. So essentially, what happens is it's about bringing the compute closer to the end user, and overall, looking at it, I would say, from our analysis, I would say the average size of an edge data center would be somewhere between 700 to 800 kilowatt.
Thank you, Gautham. Now at this time, I'm going to conclude today's session. We want to thank you again for joining us. If there's any questions or additional feedback, please reach out to us. I've displayed Gautham and Vasanth's contact details on your screen at this time. Thank you, and enjoy the rest of your day.